Hi everyone, I'm Les.
And I'm Ashley.
And you're listening to Anthropotamus, where we explore some of your favorite anthropology topics.
Hi everyone, welcome to our latest episode of Anthropotamus. Today we're here with Dr. Briana Pobiner, and we will be discussing her work at the Smithsonian, and especially her article that just came out, No Sustained Increase in Zoo Archaeological Evidence for Carnivory after the appearance of Homo erectus, which she co-authored with, and I'm going to butcher these authors' names, but Bar, Rowan, Du, and Faith. Did I say that right?
You got it. Yes, you did.
Yay. How are you doing this morning?
I am good, thanks. How are you?
I'm doing pretty good. Got the coffee in, so we're good to go.
Excellent.
So before we get into the topic, please tell our listeners a little bit about your background, how you got involved with the Human Origins Program, and what exactly is that program?
Sure. So the Human Origins Program is part of the anthropology department at the National Museum of Natural History, which is part of the Smithsonian. So it's sort of a many-layered thing. But the Human Origins Program really focuses on understanding the evolution of humans. And it's a small group of us. There's only 3 staff in the Human Origins Program, including me. And as I mentioned, we focus on understanding the evolution of humans. Mostly the research that we do is in the earlier parts of human evolution. I particularly am interested in early human diets, trying to figure out what people ate in the past and how that drove other parts of human evolution, adaptation, and behavior. And how I became involved in the Human Origins Program is I actually started as a pre-doctoral fellow. I had a 3-year fellowship, which turned into a postdoctoral fellowship, but I helped put together the Hall of Human Origins, which is a permanent exhibit at the Natural History Museum on human evolution. That opened in 2010. And then I got a permanent position with the Human Origins Program at the museum, which includes both doing my science research, which I love to do, but I also lead all of the education and outreach efforts for the Human Origins Program.
And I did glance at the website. It did appear that it looked like there was a page for resources for teachers. Is that correct?
There is. And actually, I have some great education projects going, which include working with teachers to develop and test resources for classrooms.
That's great. So new article just came out, but like a week ago?
A couple weeks ago, yeah.
Yeah.
Very recently.
So in this article, you discuss how archaeological sampling in locations like Olduvai Gorge don't actually show an increase in meat butchering by Homo erectus because of sampling intensity. Can you explain what that means to our listeners, and how does that challenge our current theories, such as expensive tissue theory?
Sure. So what we did is we wanted to look at, we know that there is an increase in the sort of absolute number, the volume of butchered bones that we see in the archaeological record starting at about 2 million years ago. So the evidence for butchery on animal fossils goes back to at least 2.6 million years ago, but it seems like there's this big increase at about 2 million years ago. And the group that I was invited to work with, led by Andrew Barr at George Washington University, wanted to just take a look and see, is this because there really is a behavioral increase in butchery, or is it because people are excavating more fossils in general from these sites that are later than 2 million years ago? So really, is it just a question of sampling? And so the more fossils you get, the more likely you are to get butchery marked bones. Or is it really that there's like relatively more butchery marked bones after 2 million years ago? So we did an extensive literature review looking for publications that included butchery marked fossils between about 2.6 and 1.2 million years ago in Eastern Africa. And it turns out that the number of butchered bones from these sites correlates pretty well with the general paleontological sampling from these different time intervals. So it was a surprise to me. I certainly expected to find that this kind of behavioral signal held up even when we looked at it compared to sampling. And so what it means and how it challenges our current theories. So there's an idea that the evolution of Homo erectus, the earliest fossils of this species, appear just after 2 million years ago, starting about 1.9 million years ago. And this is the first species in our evolutionary history that has a much more modern human-like body size and shape. It has longer legs. The limb proportions are more like modern humans, larger brains, although still kind of relatively the same size brains because their body sizes are getting bigger, smaller guts. And so a lot of the explanation of the evolution of these physical characters has been linked to meat eating. And so the idea is that guts got smaller, brains got bigger. This is the expensive tissue hypothesis, because meat is a really good source of high quality, dense nutrition. And so and that has coincided with the archaeological evidence going back actually before the evolution of Homo erectus, about 2.6 million years ago. Interestingly, we don't see the biggest increase in relative brain size in human evolution, so brain size compared to body size, until about 1 million years ago. So it may not be meat eating, because we see that starting at least 2.5 million years ago, that kind of fueled the evolution of larger brains. But also it really means that we maybe need to think about other drivers, kind of evolutionary drivers of those changes that we see with the evolution of Homo erectus.
So I should know this answer, but I do not. Do stone tool technology with Homo erectus, does it correlate with hunting, or is Homo erectus still scavenging at this point?
Ooh, that is a very good question, and one that I'm interested in my research. So I think you would get different opinions depending on who you ask. But my perspective is that we don't see really good evidence for hunting technology in the stone tool record until about 500,000 years ago. So in South Africa, there's a site called Katupan, where about 500,000 years ago, about 500,000 years ago, we really see the first evidence for stone points that were probably hafted onto spears that have impact fractures that experimentally are demonstrated to, we know that those tools were used on the ends of spears. Before then, the stone tool technology that is most prevalent are Acheulean hand axes, and those don't seem to be hunting tools. They definitely can be butchering tools. They're used for probably lots of things, including sharpening sticks and maybe even, breaking open bones to get at marrow, maybe even processing plants in other ways. But my sense is that we don't see good evidence for hunting technology until much later in the archaeological record. And therefore, it's likely that there is a lot of scavenging going on with Homo erectus.
Do you think that we can expect similar development in modern-day primates if they adopt a similar diet, or do you think that this would be more unique to our genus?
Oh, so is your question, let's say there was a primate that started eating a lot more meat, would we expect to find the same kind of, let's say, increase in brain size and other physical adaptations?
Yes, that is precisely my question. Thank you.
You're welcome. And the answer is, I don't know. That's a very good question. So I don't know. Well, I'm more familiar with the evidence for hunting in chimpanzees. And so my understanding is that, even chimpanzees who kind of hunt pretty regularly, meat is still a pretty small part of their diet. I think across chimpanzees, it's maybe 3% of chimpanzee diets. It does seem to potentially provide chimps with some important nutrition. But interestingly, also my understanding is that hunting the small monkeys, like colobus monkeys, that they tend to go after in the trees where they hang out a lot of the time, there's a real social component to hunting with chimpanzees. They don't tend to hunt most of the time until there's a particular group size. Maybe they need a certain number of individuals. Maybe there's something else going on, kind of socially. But I'm interested also, we don't have time machines. We can't go back and observe Homo erectus, but it's interesting to think about chimps, as along with bonobos, our closest living relatives, that seems to be this social component of hunting. So maybe it's not really just about diet and nutrition, but it's also about something about group dynamics.
That is actually, extremely interesting because if you look at people today, and like you said, we don't have time machines, so we can't go further back, but if you look at people today, you don't see very many solo hunters. Usually you'll go out with a group.
Yeah, and I think, we see that whether you're talking about, folks going out kind of for recreational hunting or you're going out for subsistence hunting. It's a very good point. I mean, I think people today have less to worry about in the form of big predators that they might be trying to avoid, either coming into contact with as prey themselves or as competitors. But certainly I think that like predator avoidance or so I know baboons will actually turn around and mob leopards that are trying to potentially attack them. So, I think there's a lot of like within group dynamics, predator avoidance, or, kind of predator defense strategies that may play into that kind of group hunting behavior.
So we do put a lot of importance on meat consumption in our current brain development and morphology, but there's other variables involved in that. Can you discuss some of those variables that contribute to our current human-like traits, such as food processing?
Oh, sure. I mean, there's all kinds of dietary variables that could have contributed to more human-like traits along our evolutionary history. Food processing, the like method of food procurement, of getting food, and all kinds of things that maybe don't even have to do with diets, about, reproduction, mating, and again, predator avoidance or competition with other sort of the classic, when you think about natural selection, classic factors involved in natural selection. And the other thing is that, we are complicated cultural creatures, humans. And so there are very likely, the later you get in human evolutionary history, there will be cultural factors that will be a little bit more difficult to tease out using kind of evolutionary perspectives. I still think it's really interesting and it's really possible to use an evolutionary framework to think about culture, but I think sort of the rules change a little bit.
Les, any other questions before I move on to the last one?
Ooh, okay.
I feel like you got a lot going on in your brain right now.
Yeah, no, there's a lot going on. I'm just trying to see. I'm looking at these charts here, and I'm thinking that even and I have a background in anthropology. I'm having some trouble understanding what these graphs and charts mean as far as the total amount of modified bones and things like that, and how that correlates to how that data correlates to the conclusions that we're drawing. I want to kind of ask, is there a way to simplify that for our listeners who don't have as much initiation in the discipline?
Sure. So I would say that a simple way to look at this is that as you get more bones pulled out of the ground in your sampling, you are more likely to get more bones that have cut marks. So the number of cut mark bones tends to track the number of bones that are pulled out of the ground. I hope that helps.
I think it does. So what we're seeing is just an increased number based on the total poll size. Is that what you mean? Or yeah.
So yeah, I mean, it seems like there's an increased number of butchered bones based on the like total sampling that is going on in that particular time interval. It's interesting because we do see, starting at 2 million years ago, it's not like we see, wow, there's lots of butchered bones everywhere, and that level stays consistent. There are particular places, you had mentioned Olduvai Gorge earlier, Kubifora or East Turkana in northern Kenya is another one, where we have particular places where there's a lot of butchered bones. But those are also places where researchers have been excavating for decades and pulled lots of bones out of the ground in general.
That's kind of, again, that's another interesting thing because hunting in modern primates, I believe, is observed as a learned behavior. And correct me if I'm wrong, but if hunting is a learned behavior, then they would have had to be in contact with other hunters to learn that skill set. Or maybe it was something that developed independently in multiple groups.
I have no idea. That's a good question. I don't know if hunting is a learned behavior from another group or a learned behavior that's sort of passed down from parents to offspring, or I don't know whether it's a learned behavior versus something that is sort of innate and instinctual. What is interesting about other primates is they don't tend to see dead animals as food. So scavenging is pretty rare in other primates. Um, it does seem to be something that is more unique to our evolutionary lineage.
Because we'll eat anything.
As evidenced by our current diets.
Well, sure. I mean, and exactly. But I think the other interesting thing is that what early humans may have been going after in some of these, and with scavenging with some of these earliest sites may not be the meat, but might be the marrow inside some of the limb bones. So marrow's full of fat. It has a lot of calories. It's a great resource. And very few other predators in African ecosystems can actually break open big animal bones to get at marrow. Some hyenas can, but all you need is a rock to break open a bone. And so that may have been part of really the earliest scavenging niche.
I know that you probably don't have an answer to this, but that brings a question to my mind that I've been asking every time I hear about it. And I've got to wonder what made the first, what made the first early human decide to grab a rock and crack that bone up and try to eat what's inside it? Because the bone itself, when you look at a bone, it does not look like it's super appetizing or edible.
So that's another, we need to invent some time machines, because I would like to go, and also a way to like ask early humans, so what were you thinking when you did this? And without either of those things, my total guess is that it may have just been observing other predators, eating, killing animals, eating from them. And particularly if they saw predators like hyenas chewing up bones, lions can do some pretty good damage to bones of smaller animal prey as well. So it may have just been looking at other predators and going, we can maybe figure out a way to do that, not with our teeth, but with tools.
I mean, that is the logical thought right there, isn't it? You just look, monkey see, monkey do. You see something else do it, why not try it ourselves?
Sure. Could be.
I do also wonder, because we had this discussion on fire in class, but I always do wonder, like, who's the first person to eat cooked food?
Exactly. And was it just like, a raging, like, bushfire went through and they went in afterwards and they were like, oh, this is tasty, this dead animal. You do have to wonder those things. Exactly.
That does sound that does seem like it might be the most likely case, doesn't it? Like, it was a bushfire, you got some, cooked animal there, and they're scavenging, so you give it a shot. Right?
Exactly.
I always think it's that one guy who eats everything and everybody else just waits to see if he dies.
Here, try this mushroom. Oh, that's a bad one.
All right, let's go ahead to the next question. So this article does end stating additional sampling of earlier sites will improve our understanding of hominid carnivory. That's a hard word to say. How do you feel our perception of meat consumption and early human evolution will change if we were to find stronger archaeological evidence of carnivory that is associated with our earlier ancestors?
Yeah, it's a good question. So, we, amongst ourselves, the authors, we were talking about how given given that sampling in that older than 2.2 or even older than 2 million year old time interval has been pretty minimal, the more sampling we see, the more we'll be able to see whether this pattern of butchery mark bones is really correlated with sample size. We'll be able to kind of verify that. It's not necessarily because people haven't looked, but it's interesting. It seems like there aren't sites before about 2 million years ago where you have like many stratified layers where you're finding butchery mark bones, where people are going back over and over again to butcher dozens of animals. The pre-2 million year old evidence for butchery seems to be much more opportunistic, infrequent. And so it'd be really interesting to see, is that a real signal of behavior? Is that a just signal of like geological preservation of sites? And so I think I would be, it'll be nice to see when we have more evidence from that older time period to be able to answer that question.
Thank you all for listening. Distribution of Anthropotamus is in collaboration with the American Anthropological Association. Please continue to follow us on Instagram and Twitter @Anthropotamus for our latest episodes, show notes, and book discussion schedule.